So part of this lesson is just kind of building this concept of looking at these geometric properties of algebraic functions. And specifically in this lesson, we're going to focus on those parabolas that come from quadratic functions. So this page, we're going to look at the different properties that we look at. So first off, given the equation in standard form, ax squared plus bx plus c. First off, the direction, and we'll talk more about this in units 3 and 4. If we have a positive a value, then the parabola opens up, okay, kind of like a cup, like this. And if we have a negative a value, it's going to open down. Every parabola, and we're going to look at a picture down here, I'm actually going to make this a little smaller so we can see both, has what we call an axis of symmetry, and that's the line, the vertical line that cuts it in half. So if we look at this graph, we see the dotted line is the axis of symmetry. And from the equation, ax squared plus bx plus c, we have a way to find the equation of that line. So it's x equals, we take the b value, negative b over 2 times the a value, and that will give us where that line is. The vertex or turning point of a parabola is always on that axis of symmetry. So whatever x value we found here will be the same. And then this just says plug in that x value to get the y value of the vertex or turning point. Another property we have that we've already talked about is the Y-intercept. So basically just like any graph, we're going to plug in 0 for x to find y to get the Y-intercept. Another property of a quadratic function is that the c value is always the Y-intercept. Basically when we plug in 0, ax squared and bx go away and we just have c. What we did in the last lesson, we talked about how the x-intercepts zeros or roots, we can set the function equal to 0 and solve for x. So we'll take whatever the function is, ax squared plus bx plus c, set it equal to 0, and do some sort of factoring or some other methods we're going to learn in the next few lessons and figure out what the x values are. Often we get 2 x values, right, just with the nature of factoring with x squared. So we're going to look at a couple examples and see how this works. So this one says, given the equation y equals 2x squared minus 8x plus 6, find the following. So first off, we're going to talk about that direction. So because 2 is positive, this opens up. Okay, so I'm just going to write next to it, 2 is positive. So if you look back at this, we can see how we figure it out. Write the word is in there just to make it a little bit better. For the axis of symmetry, we have the equation x equals negative b over 2a. So looking here, the b value, the number with x, is negative 8. So I have negative 8 over 2a. A is 2, so I have 2 times 2. So that's going to give me positive 8, right? Those negatives will cancel, divided by 4. So that is just 2. So this is, just to summarize, because we have a lot there, x equals 2. To find the vertex, I'm going to take this 2 and plug it into the function. So the vertex, which we'll write over here, we already know the x value is 2 because the vertex lies on that axis of symmetry. And you can look at the picture on the most recent page just to see that if you want a reminder. So then if I plug in that 2 times 2 squared minus 8 times 2 plus 6, this evaluates to negative 2. So once I find that number, that is the y value for the vertex. The y-intercept, we plug in 0, and I should already know also from what we said that it's going to be 6, but I'll just show it this once. So we can see why it's 6, and so it's not just a formula. So when I plug in 0, everything else goes away, right? And I just get the 6. The x-intercepts, we're going to set that function equal to 0. So I have 2x squared minus 8x plus 6. I notice that we have a GCF here, so I'm going to take out the 2 to make this factoring easier. Avoid the arc method. And then numbers that multiply to negative 4 and add up to 3 are negative 3 and negative 1. So this gives me answers, or zeros, of 3 and positive 1. So it doesn't say it here, but I'm just going to show how these qualities are definitely sufficient to draw the shape of the parabola. So first off, I'm going to start from the vertex. So 2, -2 would be about here, and this is just a rough sketch. The y-intercept is 6. So this is somewhere up here. We'll say that it's a little disproportionate, but the y-intercept is up here. We have zeros at 1 and 3. So I can draw it in now, and as I said, it's not, super symmetric in terms of I don't have another point on the right side, but I can see my parabola. I can see based on the points I drew that it does open up. And I can also see that if I did draw in that axis of symmetry, which is not really a part of the shape, if I had drawn my graph a little better, that would be the true axis of symmetry. This side needs to move over to that direction a little bit more. I will see if I can get it erased decently. A baby eraser. And then at least we're coming close, right, to looking like it's the correct axis of symmetry. So in this day and age, we have graphing calculators. We can graph it to see it, but understanding that the qualities of the algebraic expression give us the properties of the shape is the main concept here. So let's look at one more. So we have -x² minus 6x plus 7. Just going through them kind of quickly, and I do suggest you try this one on your own first. Our first thing is direction. So we have a negative a value, so we're going to say that we can tell that opens down. My axis of symmetry, -b over 2a. So that's going to be -6. Lots of negative signs here, you'll see, over 2 times -1. My a value is -1. So I am going to end up with a negative number here because I have 3 negative signs, and that's -3. So we get x equals -3 is the axis of symmetry. The vertex, plug that in. So we have, and I'm going to write it with the function notation. So f of -3, we're plugging in -3. -3 squared minus 6 times -3 plus 7. Now I'm just using technology to find this, but this is the first thing if we were doing it by hand in PEMDAS that happens. So that becomes +9, and then the outside negative sign makes it go back to -9. So through that process of simplifying that, I have -9 plus 18 plus 7. So I'm going to get +16 there. So my vertex is -3, +16. We'll just make sure we have all the different answers clearly labeled. The y-intercept is 7. And you can know that. That's enough that you don't have to show the plugin. You can just know that it's the number by itself because 0 will make everything else cancel out. And then x-intercepts. I'm going to factor out a -1 just to make this next step easier. And then I have +7 minus 1. This -1 equals 0, just like this 2 equals 0, right? That doesn't mean anything, so that's gone in terms of the solving. So I get -7 and +1. And just to make sure all my properties agree and make a cohesive figure, when I draw it, it should open down. My vertex is -316. We're just sketching this, so we're going to say it's somewhere like up here. The y-intercept is 7. Yeah, we'll move it down about there. And then my roots are at +1. And we'll say -7 is somewhere over here. Okay, and I definitely don't have even in terms of my y and x scales because I'm saying that this is 16, which is fine. But we can see that all of those properties fit with the shape. So for your homework, which is on Delta Math, there'll be little questions that are very similar to this page of the notes. The first few pages of the notes, when we talked about algebra and geometry coming together with a coordinate plane, are more just like a concept that we'll keep working on throughout the year as we work with different types of functions on graphs.